Here we go. Today's lesson is called the unit circle. Okay, and this is very cool. Actually, yeah. All right. This lesson, and I say this every day, but I'm really telling the truth this time. This is fundamentally important for this unit and the test and grade 12 math and calculus and everything else. This is the first sort of really important thing to do. Okay, so what we're going to do is this will show where sine and cosine actually come from. Okay, so this is, again, using, math to show you where these numbers actually come from on your calculator and all that stuff. That's what we're getting into here, okay? So what we're going to do is we're going to draw a circle on the board with radius 1. Okay, this is going to be called the unit circle. We use this one a lot. Sorry, yeah? Can anyone guess why it's called the unit circle? What does unit mean? Unit means 1, right? So it's a radius of 1, okay? Okay, so take a second and scribble that down. And then we're going to pick a point P somewhere in the first quadrant. It doesn't really matter where. Okay? If you weren't here yesterday, one of the things that we showed was that, again, 0 degrees is starting here and you're rotating up this way. That's what theta comes. Remember the numbers that from yesterday that was here? Right, again, so you're starting here and you're rotating around. So theta is actually measured from the positive x-axis of 0 and then rotating counterclockwise. Okay, I'm going to slow down here because I need people to... All right, next thing I'm going to do is I'm going to just draw a little dotted line down the middle, sort of like this. And I'll get the right angle out of that. That's what I'm going to do. Is this coming back to the middle or not really? Yeah. All right, I'm going to do a zoom in on the next board here, okay, because this is getting sort of complicated for your circle. Okay? I'm going to make a circle. No. Oh, that'd be cool if I did, but no. So what I'm going to do is I'm going to draw a beautiful triangle, beautiful right angle triangle with a theta right here. Okay. All right, so this is where I need 3 moments of inspiration from 3 different people. Can someone please tell me what the length of the hypotenuse is of this triangle? This is based on that circle. Go ahead. 1. Good. Excellent. And again, that's just all this is a zoomed in version of that. What is this value up here going to be? Okay. No, not 1, because if it was 1, it could potentially be if it was up here, right? See what I mean? So it's going to be a little bit less than that. Yeah, right? Could be, depending on how the angles go, okay? I'm going to give it not a number, I'm going to give it a letter instead. Yeah? Could be. Yeah, this is going to be your y value. And that's going to be it. Yes, it certainly does. It's horribly much. Think of your graph. You can't remember which is which. Think of like how a graph goes, right? So if this is this is your y coordinate, right? So the distance from this is just whatever that y coordinate. That's your x coordinate, so that's the unit of the x coordinates. And you're probably saying to yourself, Mr. Sadler, how does this make me improve as a math student? I'm going to show you right now. I'm going to pick on Austin, since you and I are best friends, since you said good things about me on that piece of paper. If I were to say sine of theta, go back to grade 10. What is sine theta equal to in grade 10? Very good. Now, you're not done yet, best friend. What is the opposite side and what is the hypotenuse on that triangle? Y over 1. Very good. Therefore, sine of theta is the y coordinate on the unit circle. Okay, and this is hideously important. Sorry, Tristan, you missed the most hideously important thing because of this here.
I think the only person that says hideously
Is me. I'm going to hit pause for a sec. Because I want to talk about my friend that I'm not allowed to talk about. That's not your friend. I have no friends.
I thought Austin.
So can we do the same thing here? And can somebody try and be brave and do the same thing for cosine? Do these for all. Luke, go ahead.
I'm guessing it's X.
Good. Can you prove it to me?
First sine was Y.
Good. So prove it to me. It equals. Go ahead. Yeah.
So,
Good.
why do I have to prove it? Which is fair.
Because I'm going to ask you to prove on your test. Because cos theta is the x coordinate. Just wait. Just wait. Don't give it away. You just wait. Just relax. Breathe in for a sec. Because this is deep and scary to most of 99% of the class right now. It is deeply scary. Right? Okay, we're going to do tangent next. And since Liam has a question about it, Liam, can we give me the equation for me, please? Go ahead. And I'm going to just write you right now. Hopefully you're feeling good about this. Sine is y, cos is x, tan is y over x. When you go back to grade 9, what does y over x mean? What does delta y over delta x mean in grade 9? Slope. Good.
Bless you.
Tan of theta is the slope from the origin to point P.
So wait, if tan was like 33 degrees, the slope would be.
No, if theta was 33 degrees.
Yeah, that's right.
Yeah.
And the slope would be.
Whatever. Okay, and that's why remember we talked about tan 45 was equal to 1. So that's the slope, a rise of 1, a run of 1, the slope would be 1, right? Now, going back to my circle, I know this is deep, so I'm going to try and talk slowly because this is deep. I'm going to try and do breathers, okay? Are we okay on sort of how I got this, okay? Right, so it is triangle, break into x and y and all that stuff. I'm going to do application with it and show you how it works and make sense to the world here in a minute, okay? But the 3 things you need to know are, where's my written today? Yeah. When I say sine, what variable do you instantly think of when I say sine? Lovely, tremendous. Cool. When I say cos of theta, what do you instantly think of? And when I say tan, what do you instantly think of? Quinn? Okay, which is slope. Okay, now it's those 3 things are hideously important. Okay, I said that a lot here, right? Okay, but it's those sort of decommitted to memory. You can prove them yourself here; they're not hard to prove again. It's using the triangle, but as you're getting around, we'll deal with graphs and all that stuff again here too. Yes.
But it only works if the hypotenuse is small. So the hypotenuse.
Well, if the hypotenuse is 2 ideas, the x and the y are bigger than that, right? Like the ratio still works. Like as far as the ratio, it still works to be the same. Okay, so if the circle is bigger, like really technically, and this is the way Mr. Walter teaches, I don't teach it this way. Mr. Walter would say that sine of theta is equal to y over r.
Yeah, my teacher.
That actually.
If you go with that, then go with that. Okay, so.
Are you only going to make it seem like
Okay, so here we go. Let's just start with some examples here. Solving enemies. Example 1. All right, this question will appear on your test and also on your assignment, I guarantee. Okay. Okay, if, for the other 99% of the class that doesn't remember this, please pay attention to that, okay? So it says, sketch sine of theta equals 0.21 on the unit circle and solve. Now this probably before today you'd say, what the heaven does it even mean, okay? And even now you might be thinking the same thing, all right? What I would like is a break. We're going to do by row here right now rather than doing Spider-Man today. Can some, so I'll give a second to scribble because I'm too excited. Did anyone write on a piece of paper, Mr. Sadler, should just relax and just talk in a monotone voice? I wish somebody would say that one year.
I do appreciate it.
Oh, okay, I'm gonna hit pause. You weren't here when I told this joke, okay? My
It's, I just said the negative is like when you look at us and you're like really disappointed because we don't know something like collectively as a group. And I drew your face. What does that say?
Okay, so it says here, sketch sine theta equals 0.21 on the unit circle and solve thetas between 0 and 360. So I want the angle to be between 0 and 360. All right, so Leah, since I picked on you before, when I say sine theta, what does that actually mean? Y. I'm going to say Y. So what we're going to do, okay guys, 1 second. So what I'm going to do is I'm going to draw Y equals 0.21. So I'm going to make a beautiful circle, like such. There's my X, there's a 1. There's a 1, there's a negative 1, there's a negative 1.
We draw circles again.
The best that you can, yes. And so what I'm going to do here is I'm going to put at 0.21 for Y, I'm going to put a little hash mark right here. I call that 0.21. Because that's Y equals 0.21. Are we so far so good? Okay. The problem is I'm not hitting the circle. Okay, so how would I get a theta for that? What would I do? Yeah. Nope. The circle stays at 1. Circle never changes. I'm going to help you out here, so I want to save time here. So what I did was, this is a point on the circle, right, where Y equals 0.21. So my theta is going to look something like this. Okay, so going back to grade 10, how do I solve for theta here right now? Yeah, guys? Sine inverse, good. 12.2. 12.2 what? And of course, you should all be furiously struggling that, or calculating that. Okay? 12.12, okay. Now, that's good, but it is not yet great. Okay? Other than the 2 people that did this before, I'm going to say that that's not the only answer. What's the problem with that? When else can Y be 0.21? Other than the 2 people that have seen this before. Okay? So what Liam said is correct. Okay? If you extend the circle over here, okay, there's going to be another point that actually works. Where's theta going to be for that one? Yeah, so again, you're starting, made the hand signal, I'll show you what you said. You're going to start here and it'll go all the way around. So it's starting right here at the x-axis again and going to there. Now the difficulty, and please don't choke this one out, please, Liam, okay? The difficulty is that my calculator will not give me that angle, okay? If I do sine inverse of 0.2, it's already told me that it's 12.21 degrees. Is there a way I can find that big green angle, Skylar? Close, but no, almost, okay? Because the problem is this little angle here clearly isn't the same as this one here, right? Like, it's not going to be the same as that. What can I do? Yeah, go ahead. Yeah, 180 minus, okay? If you look here, this little arc there is going to match that little arc there, okay? So we're going to say my green theta is going to be 180 minus 12.12, which is 167.88. Can you confirm that for me? Now, if you don't believe me, and most people don't, type in sine of 167.88 and see what you get. Yeah. 0.21 or something very close to it?
Yeah.
Yeah, someone question?
So that green angle is all the way from that first
Yeah, not from the first line, like from the positive x-axis. Yeah, from the flat one. Okay, so remember, this is where always with 0 degrees is measured from, right? Okay, so the thing is, now let's say I change the question from 0 to 360. Just for those people to make sure you guys are still awake from yesterday. What would a coterminal angle be to 12.2 degrees? What's a coterminal angle to 12.2? Go ahead.
Something that is in the same spot.
Good, but what's the number exactly? What number would that be going? Yeah, so what should actually what should actually happen? If I type in sine of 371 point, no, was it 372.1? That should also give me 0.21. Okay. So the idea is please go here, guys. I know the rugby team wants to get going, just give me a minute here though, okay? So whenever you add a multiple of 360 to each angle, it should give you the same answer here. So sine of that should still work out. Now this is fundamentally important for trig. Oh, what I just did was I added 360 to it. That's actually too big, so I dunked on your sister yesterday, so I'm going to dunk on you today. Okay, so here's a slam dunk of 20-degree dunk. So what I'm saying is I'm a great jumper, so I'm going to do this instead. So I dunked on you again in the same final position, but instead of rotating 30, I did another 360 to it, so it's 390. So 360 always gets you around the circle again the same way. So as long as the final position is the same, the angles are equivalent. So 371.12 is equivalent to 12.12 degrees. So that's what we're saying. Yeah.
So coterminal has to be bigger or smaller?
Yeah, or bigger. Right.
And you can add anything to it that's a multiple.
Yes. Okay, I'm gonna do the same thing for coast here right now. Rugby girls, are you escaping? Or not yet? Okay. Yes.
Why don't you 3,000?
Because I get too dizzy, I don't want to. Example 2. I'm gonna hit pause here for one side. I'll write it on the board and then you guys can try it. Example 2, I'm gonna say sketch. We'll say cos of theta equals 0.6. And solve 0 degrees is less favorable to theta is less favorable to 360. So solve this example the same way, except for think of what cos will mean. Cos is not going to mean y, it's going to mean something else. X. So solve where x equals 0.6 and draw it and see what you can do. I'm going to pause in the video. 19 minutes. No one's going to watch this.